friends, myself B.A. Sharath Manohar Babu, Associate Professor, St. Peter's Engineering College. In this video, we are going to understand the Intel 8086 microprocessor architecture. We are going to look some more features and the functioning of 8086 microprocessor further videos. Let us look into the brief introduction about the microprocessors. In the year of 1970, the Intel Corporation has launched the first microprocessor named as 4004, which was a 4-bit microprocessor with 4 kilobytes of memory. Afterwards, the Intel again launched the 8085 microprocessor, which was the first 8-bit microprocessor, which is a very important microprocessor because most of the important features from 805 only are carry forwarded for the next generations of microprocessors. Later, the Intel invented the 16-bit microprocessor such as 8086 with the advanced feature again 80286. Afterwards, the Intel invented the first 32-bit microprocessor 80386. Afterwards, again 80486 with some more advanced features. Later, Intel Pentium processors have came into existence. Later today, we are using Intel Core 2 I series processors. This is a brief history and evolution of microprocessor. Let us look into the Intel 8086 microprocessor architecture in detail in this video. In this video, we are going to come across the several points such as the 8086 processor features, its architecture, the register organization, and how the memory has been segmented, and finally the physical address calculation. These are the following points we are going to discuss in this video. Let us look into the features of 8086 microprocessor. The 8086 microprocessor belongs to Van Neumann architecture. If you want to understand what you mean of Van Neumann architecture, it states that both program memory and data memory are same. Means the address bus and data bus are same. But whereas in the case of Harvard architecture, the both program memory and data memory are separate. That is a major difference between Van Neumann architecture and Harvard architecture. Most of the microcontrollers construct under Van Neumann architecture and most of the microcontrollers are constructed under Harvard architectures. Now let us look into some more features of 8086 microprocessor. It is a 16-bit microprocessor, means the CPU can perform arithmetic and logic operations on 16-bit data. And the 8086 microprocessor has a 16-bit address bus, which gives us 1 MB of memory. Means the 2 power 20 address lines will give us 1 MB of physical memory. And 8086 has a 16-bit data bus. As we have stated that it is a 16-bit microprocessor, it has to perform arithmetic and logic operation on 16-bit data and the data to be carried in this 16-bit data bus. And also points state that the 8086 processor has a word length of 16-bit. Means on how many bits the CPU can perform the arithmetic and logic operation is known as word length. The 8086 microprocessor is a 40-pin dual inline package. Most of the microprocessors and microcontrollers are constructed with dual inline package, and the operating voltage of this 8086 microprocessor is 5 volts and the operating frequency of this 8086 microprocessor is 5 to 10 megahertz. Now let us look into the block diagram of 8086 microprocessor. The internal architecture of 8086 microprocessor has been divided into two major blocks such as bus interface unit and execution unit. The bus interface unit generally used to provide the required data for execution purpose. The various blocks present in bus interface unit are the address summer, segment registers, instruction pointer, and importantly the instruction stream byte queue. We are going to discuss about this instruction stream byte queue in the further slides. Let us look into the execution unit. It contains general purpose registers, stack pointer, base pointer, and index registers, and also arithmetic logic unit, flag register, and control unit. These are the various blocks present in both bus interface unit and execution unit. Now let us look into the functions of this bus interface unit and execution unit. The bus interface unit is used to provide the data as well as address required for execution by the processor. The bus interface unit provides the data fetched from the memory location or registers and to be provided to execution unit. The execution unit contains the control circuitry, instruction decoder, ALU, pointers, index registers, and flag register. So we are going to discuss about this each and every register in detail in the further slides, but we need to understand the major importance of this bus interface unit and execution unit, as that the bus interface unit provides the required data fetched from the memory location and sent to decoder present in execution unit one by one. Before sending into decoder, it preserves the data in the instruction stream byte queue. This is the most important feature of this instruction stream byte queue present in bus interface unit. Now let us look into the some more important features of bus interface unit. Is that, as we understand that it has the bus interface unit contains the instruction stream byte queue, which contain 6 bytes of data. This instruction stream byte queue is also known as prefetch queue. Means it prefetches the 6 bytes of opcodes from the memory location and kept in a queue format. The queue performs on the principle of first in, first out. From this instruction stream byte queue only, the byte codes are going to be sent to the decoder after decoding, and it would be sent to execution. This is the main important block present for understanding the concept of pipelining in 8086 microprocessor. The pipelining can be defined as fetching and decoding and execution. The first step of operation called fetching. This fetching can be done in 8086 microprocessor by this instruction stream byte queue. It prefetches the opcode bytes and kept in a queue and send one by one to the decoder. From there it decodes and send to the ALU for execution process. This entire fetching, decoding and execution process is known as pipelining. This is the most important question you may be asked in the university examination for 2 marks or 3 marks. The other point of bus interface unit, it contains segment registers. The 8086 microprocessor has 4 segment registers called code segment, data segment, extra segment and stack segment register. All these registers, the segment registers, are used to store the starting addresses of the various functions. Let us tell you that the code segment register is going to store the starting address of our program. The data segment register is used to give the starting address of the data, and the extra segment register is also an additional segment for data, and the stack segment register is used to give the top of the stack value which is ready for the execution purpose. The instruction pointer register will give us the next instructional address. Once the first instruction taken from the code segment register and got executed, the next instructional address would be given by this instruction pointer. And this bus interface unit is also contains a special block called the address summing unit. The main function of this address summing unit is to calculate the physical address. If you look into the memory organization of 8086 microprocessor, it has 1 MB of physical memory. Means this physical memory can be accessed by writing the address in the 20-bit format. But the user is going to use the address called offset, which is in a length of 16-bit. So whenever user uses the address in 16-bit, the CPU has to convert that 16-bit address into 20-bit address. This is the main function of this address summer. The address summer is used to calculate the physical address by means of converting the user offset address into 20-bit CPU address or system address. This is the main function of this address summer present in bus interface unit. Now let us look into the features of execution unit. It contains a decoder. As I said earlier that from the instruction stream byte queue, one by one byte is taken from ISB queue and get into the decoder. The decoder is used to decode the hexadecimal opcode bytes into binaries, and it sent to the ALU. Finally, it get executed. And it has a control register which is look after the control signal accessing, and the flag register present in execution unit is used to tell the status of the CPU after performing any arithmetic logic operation. Means if a CPU performs any arithmetic or logic operation, these flags are going to be get affected depending upon the conditions or controls occurred in 8086 microprocessor operations. Now let us look into the register organization of 8086 microprocessor. Basically, the registers of 8086 processor can be categorized into two types. One is general purpose registers and another one special purpose registers. We have four 16-bit general purpose registers named as AX, BX, CX, DX. These four 16-bit general purpose registers are again subcategorized of each into two 8-bit registers, such as AX is a combination of AL and AH. AL stands lower byte of accumulator register and AH stands higher byte of accumulator register. AX is known as accumulator, BX is known as base register, CX is known as count register, and DX is known as data register. So these are the four general purpose registers present in 8086 microprocessor. Now let us look into the classification of special purpose register. The special purpose registers are again categorized into three types. They are segment registers, pointer registers, and index registers. As earlier we discussed about the segment registers like code segment, data segment, extra segment, and stack segment, which are used to give the starting addresses of the program and data for execution purpose. Likewise, the pointer registers are used to point some addresses for the CPU execution purpose. Let us look into the different pointer registers present in 8086 microprocessor. Is that instruction pointer, as I earlier discussed, that instruction pointer gives the next instructional address for the execution. The stack pointer is used to give the top of the stack value from where the CPU takes the execution address. The base pointer points the base address. The base pointer is used to point the base address. The base address is also known as starting address. The one more special purpose registers we have in 8086 microprocessors are index registers. We have 8086 SI and DI, source index and destination index register, which are used to give the addresses whenever user want to access some memory locations for his operations. SI stands source index register and DI stands destination index register. These are the some general features of this general purpose registers and special purpose registers. This SI and DI are especially used in string manipulation programming. Now let us look into the some more important features of this register organization. Especially in the university examination, you may be asked to write about the special features of general purpose registers. Generally, we used to write about AX, BX, CX, DX registers. They are generally a data register, but if you have been asked in a university such as to write its special features, you must write like this. The AX is also known as an accumulator. Though it is a general purpose register, specially it is used to store the result after any arithmetic logic operation by default. That is the speciality of this AX register. Next, coming to the BX register. Now coming to the BX register is generally used to store the data, but in special case this BX register is also used as base address register in relative addressing modes. The CX register generally used as data register, especially in recursive programs or iterative application. The CX register is used to store the count value in our programming. DX register is also a generally data register, but especially in multiplication and division operation, the additional answer would be stored in DX by default. So like this, you need to answer these special feature of this general purpose registers. Now let us look into the some most important topic called flag register. Generally, the flag register is also known as status register, because after performing any arithmetic logic operation, the flags are going to be get affected depending upon the conditions or controls occurs in a processor. Now let us look into the flag register of 8086 microprocessor. The 8086 has a 16-bit flag register which contains 9 active flags. The remaining bits are kept unused, means the remaining unused bits are kept reserved for the future purpose. Let us look into these 9 active flags. What are the flags? These 9 active flags again categorized into 2 types. In that, 6 flags are known as conditional flags and 3 flags are known as control flags. Out of that 9 active flags, the 6 conditional flags such as carry, parity flag, auxiliary flag, zero flag, sign flag and overflow flag. These are the 6 conditional flags are going to be affected whenever appropriate condition occurred in arithmetic logic operation. Let me give you one example. If you are adding two 16-bit number and you have obtained one additional carry bit, then the carry flag is going to be set. Now look into the parity. If you perform any operation, if the result contains even parity, then this parity flag is going to be set. The auxiliary carry flag is going to be set when the carry propagates from lower nibble to the higher nibble, or the d3rd bit exceeds and shifted into the next nibble position. In such cases, this auxiliary carry flag is going to be set. The next one, the zero flag. If the result after performing any arithmetic logic operation, if the result is 0, then the zero flag is going to be set. Otherwise, it would not be set. Now let us look into the sign flag. Whenever the result obtained negative, then the sign flag is going to be affected. The last conditional flags we have is that overflow flag. Especially in multiplication and division, we can occur this overflow flag. Let us take one example. If you perform 10 divided by 3, where we are going to get n number of 3.3333 like that. So extra results we are going to get, but infinity of 3's we are going to get after fractional point. In such cases, the CPU automatically enables this overflow flag. So based on these conditions, these flags are going to be set or reset. Now let us look into the three different control flags we have in 8086 processor is that interrupt flag, trap flag and directional flag. Let us look into the interrupt flag. Whenever CPU gets interrupted, the CPU is going to enable this interrupt flag. The trap is also an interrupt related flag only, but the trap means single step executional. We have a provision in 8086 processor not to compile, even we can execute step by step. In such cases, this trap flag is going to be set. The last control flags we have in 8086 processor is the directional flag. Especially in string programs, this directional flag is going to be set or reset depending upon our requirement. Now let us look into the, so these are all the flag register explanation what we have discussed. Now let us look into the most important topic called memory segmentation. As we have stated that the 8086 microprocessor is having 1 MB of memory and it has addresses 5 zeros to 5 Fs. In that memory, we have various segmentation. The major need of this memory segmentation is used to present in any microprocessor or microcontroller for better accessing of memory locations by the user. It is for our convenient only we are going to partition the memory, such as if you take your laptops, we are going to divide the 1 terabyte of hard disk into various drives, C drive, D drive, E drive, like that. So better you understand this example. In the same fashion, the 1 MB of memory has been divided into various segments. So in 8086 microprocessor, 1 MB is divided into two equal banks, even bank and odd bank. And also it has four segments such as code segment, data segment, extra segment and stack segment. Each segment capacity is 64 kilobytes. Each segment capacity is 64 kilobytes. Code segment is used for saving the program. Data segment is used for saving the data or fetching the data, and extra segment comes into a picture when data segment register is completely utilized, and stack segment is used to store the current executable information. The stack segment register is used to store the current executable information. Whatever the instruction that to be want to executed present, that would be stored into the stack segment register. Like this, the 8086 processor has been divided into various segments such as code segment, data segment, extra segment and stack segment with equal capacity such as 64 kilobytes. Means whenever user want to access program or data, he need to address 16-bit. Means as I told you in the physical address calculation, the user address want to be converted into physical address and the user address would be in 16-bit length because this segmentation only. So all the segments have the same capacity called 64 kilobytes. If you want to access that 64 kilobytes, the user has to write an address in the length of 16-bit. 2 power 16 will give you 64 kilobytes. Better you hope you understand this point. Next we'll look at some other points of physical address. Already we have discussed how the physical address. Now with this slide we can understand how we are going to calculate the physical address. In 8086 microprocessor, the physical address can be calculated by this address summer block present in bus interface unit, which is having a logic with a formula called 1 nibble shifted left segment register value plus offset address. Right? Once again I am repeating the formula: 1 nibble shifted left segment register value plus offset address, that will give you the complete 20-bit of physical address. So like this, the physical address can be calculated by the CPU in 8086 microprocessor. Hope you understand some of the points of 8086 microprocessor features, registers, and what are the special features of a register and what is the instruction stream byte queue. In this video, in the further videos, we are going to discuss some more additional points of 8086 microprocessor. Thank you for watching.